Evening, sir.
Yeah, good evening. We will be starting our session in around, let's say, 5 minutes. We'll wait for others to join and then we will start.
Sure, sir. Sure, sir.
Sir, আজকে পার্থ স্যার বলেছে, ঠিক আছে, কথা বলেন। Okay, fine. So we will start our live session today. I will start by introducing myself. My name is Rajarshi Bhar, and I have been assigned as one of the TAs for this course on integrated waste management for a smart city. So I am currently doing my PhD in IIT Kharagpur under the supervision of Professor Brajesh Kumar Dubey and Professor Makaran Madhav Gangrekar. So today is the week 5 live session, as you can see, and in today's session we will be having 15 questions, which will be a mix of both. There are theoretical questions as well as there are numerical questions, and in the end there are few questions with multiple correct answers can be there, like more than one of them. So this is today's mix. And in case if you are having any doubts, any points that you would like to highlight or share your experiences, you can interrupt me at any time you want, and we will have any such sort of knowledge sharing session today. So moving on with our first question today, it is you have been given that in the equation of material balance, if now these are the four conditions. First option, rate of accumulation of material within the system boundary. Second, rate of material flow into the system boundary. Third is material flowing out of the system boundary. And fourth is generation of waste material within the system boundary. So you have to say that which of the following statements that I will now write is correct. Okay, so these are your options. You can think about it and please share your answer in the chat box, or you can unmute yourself. Okay, option B is the correct answer. As you can all see that the rate of accumulation will be, first is point number 2, which is rate of material flowing into the system. Then we have to subtract the material that is going out of the system, which is very obvious. And plus 4 means any, if that certain material is generating inside the system any mass, that will be an addition. So option B is the correct option. So some of the examples where this kind of concepts can apply, it can be landfills, wherein let's say you are trying to track the amount of waste material that is coming in the system and generating in the landfill, total amount of waste that is accumulating in the landfill. There, this kind of concept can be used. Otherwise, let's say if you are studying let's say a lake, wherein some certain amount of contaminant, it can be any nutrients or something that is coming into the lake, or some other contaminant that is generating by itself in the lake due to various chemical reactions. So mass flow of such contaminants, it can also be tracked through this material balance concept. Now moving on to the next question. It is a easy numerical based one. Okay, so this is your question. You have to find the resulting number of moles of water that will be formed when 10 moles of oxygen reacts with 10 moles of hydrogen. So please calculate this, and I will be sharing the options with you, let's say in 2-3 minutes. Okay, so one of the options we have got, it is answer is 10 moles. Someone has already solved it. I will wait for some more time for others to share their answers. Okay, so 10 moles is the correct answer. Like, as most of you have already guessed it right. So in order to solve such questions, first we have to write the chemical equation by balancing the number of moles on both sides. So I have got hydrogen, which reacts with oxygen to form H2O, and if you balance it, it will become 2 moles of hydrogen. It reacts with 1 mole of oxygen to form 2 moles of water. So in this way, you can see that the number of moles of water that will be formed, it is equal to the number of moles of hydrogen that it takes place in a that interacts in a equation. So number of moles of hydrogen that we have is 10 moles. So that is why similarly the number of moles of water that will be formed, it will also be 10 moles. So those who have got the answer as 10, it is correct answer. So moving on to the next question, which is a theoretical type of one and very easy. Which of the following So which of these the following options will be are not needed to be considered while designing the solid waste collection system of a community? You have to select the option which is not needed. So option A, okay, very easy question. Which of the following are not required for designing the collection system of waste in a community? Option C is one of the options that has been highlighted, and it is also the correct answer for this question. So moving to the next one. This is about backyard composting and which of the following options are necessary or are required to be considered while going for this backyard composting. Okay, these are your options. Okay, so most of you have selected option D, that is both A and C are correct, which means while designing or going for a backyard composting, one needs to select the size of the composting unit, very important, and then also there's a need for maintaining sufficient contact with air, which is done by mixing it. And also some few points, as we all know that while we are doing composting, since it is basically an aerobic process, so methane released during composting, this can be completely ignored, as if at all it is generated, it will be negligible amount or very insignificant one. Secondly, in composting, what happens, like the two basic components we need is water as well as air. So we have to mix it continuously after some time, because let's say you have mixed the compost initially or put some initial material, let's say food waste and leaves and all. So what happens that when you let it stay there for some time, the temperature of that heap or that this composting unit, it starts to rise, because the kind of reactions that is taking place there, those are exothermic, not endothermic reactions, which means there will be generation of heat. Heat exothermic है कि endothermic? Generate high exothermic. Sorry, so it will be exothermic reactions where the heat will be generated. So that is why once the heat is generated, it is due to the metabolic activity. So if that is not controlled and it rises above a certain level, I think it is 50 degrees centigrade, then the bacteria which are present there that prepare the compost, they gradually their activity starts to decrease, and after a certain level they begin to die off. So that is why it is very important, so that we keep on mixing it, and the temperature is also lowered in that way, and we can maintain an optimum level of temperature which is sustainable enough for the microbes present there. Now moving on to the next question, which is again a numerical based one. Okay, so this is your question. You have to determine the number of houses in a colony with an average occupancy of three people are there in per each house, that generate two containers of waste per week, and that volume is after compaction. So you have been provided the solid waste generation rate and the specific weight of the solid waste, and you have to determine the number of houses which are there in a colony. I will be sharing the options with you in 5 minutes, and in the meanwhile, you can think about the question. Any answers? You can please share it on the in the chat box. One 140. Okay. I have given you the options. Now you can cross check or find if some. I have given you the options. You can, I have seen 140 as one of the estimates. Maybe you can again go through it and see if anything else can be added or removed. Option D, okay. 150 is what most of you are suggesting. We will wait for another 4 minutes, then we'll start solving the question. Okay, so we have got another option 200. Now we will start solving the question and see what is it actually. Occupancy rate is 3 people per house, and each house generates 2 containers, 7.5 meter cube per container, and the compacted specific weight is given here. So based on this few data, let's see what we get. So waste waste generation per week. So this is the weekly waste generation. So daily waste generation will be, this is the daily waste generation. So what is the per capita or per person waste generation per day is also given, which is, so this is per capita waste generation per day, and this is total amount of waste generation. To determine the number of people, that will be number of persons is equal to 530 5.7 divided by 0.6, which will be about 893. And so the number of households will be, you have been asked to determine the number of houses. That will be, since there can be three people in one house, so we have to divide it by 3. It is coming around 298. So the closest option is 300. So 300 should be the correct answer. If you have any doubt on this, please feel free to unmute yourselves and share that. I will again just repeat the question. So you have to determine the number of houses in a colony. That is the question. And occupancy rate has been provided to you, that 3 people are there per house, and there is a waste generation of 2 containers. So based on that waste generation per week, so this waste generation is total amount of waste that generates. Then based on that, so 2 containers of waste are generated with the volume of each container being 7.5 meter cube, multiplied by 250. 250 why? Because the waste is has been compacted and the compacted density has been shared with you, 250, followed by, this is the total amount of waste that is generated per week. Then you can calculate the daily waste generation, followed by per capita waste generation has been provided to you. Then you can divide it and get the number of persons who are generating this amount of waste, and finally number of houses. So I think in here this can be a confusing part in this question, that some of you must have thought that occupancy rate of the house is 3 people per house that generate 2 containers. So this, I think most of you may have taken this as that 2 containers are being filled by each household, but that is not correct, because 2 containers is being filled by the entire community. So that is how we should go ahead, because the compacted volume is 7.5 meter cube, and it is very unlikely that just a single household can fill this 7.5 meter cube of compacted bin in each week. So that was the solution for this question, and the correct answer is 300. I hope that is fine by everyone. If there is any doubt, please feel free to unmute yourselves. Now we will move on to question number 6, which is a normal theoretical based one. Very easy question. You have to find like which of the following waste management practices helps in diverting the waste that is being dumped in a landfill. Okay, so these are your options. Yes, option 4 is the correct answer because by going for all these above three approaches, you can divert the waste from the landfills. Now, moving on to the next question. It is about the transfer stations and its role. What are transfer stations designed for? SWS solid waste. Okay, so what do you think about it? Option 2 and option 1 is what everyone is saying. Any other thoughts? Okay, so option 2 and option 1, these two are the confusing options. So there is a transfer station, so its primary reason why it is there is not to minimize the haul distance. Yeah, minimize the haul distance, it can be there, but there is a hidden point in it, which is being addressed by point number 2, that is to minimize the cost of solid waste transportation. Now, what happens is that when the solid waste is being collected from each household, because in household and all those areas, colonies and residential areas, the alleys or the roads are usually narrower than what we found on expressways or highways and state highways. So let's say if small vehicles are there which are collecting the solid waste from individual households, and there is no transfer station is in existence, and that small those vehicles they are supposed to directly carry your waste to the landfill. So in such instances, what happens that the total fuel consumption due to number of small vehicles which are going to the landfill, it has been found that it is very high. On the other hand, what we have observed is that, for example, if there is a transfer station in between somewhere from my from the residential area to landfill at some intermediate point, so my smaller vehicles they will first carry their waste to the transfer stations. From there, larger trucks will be there who wherein the waste will be loaded, and then fewer number of larger trucks they will take forth the waste to the landfill. So in those instances, the overall fuel consumption also decreases considerably, which as a result minimize the cost of solid waste transportation. So that is why the minimization of the cost of solid waste transportation, it is the major reason of why the transfer stations are introduced. And in that way, if someone is thinking that minimizing the haul distance, so that can be one way to say it, but it is not actually complete. So the goal can be to minimize the haul distance of the smaller waste collection vehicles which are collecting the waste from the households. So the correct answer in this question is minimizing the overall cost of the solid waste transportation. I hope this answers the question. Now moving on to the next one. It is kind of a numerical based question. SW is again the solid waste. 2 tons per day. That's just a solid waste generation. Okay, so this is a transfer station. Solid waste that is coming in is 2 tons per day. From there, some amount is recycled, incinerated, and composted. So what you have to do is that from the above quantities of the different waste, you have to find or calculate the amount of waste that is being transferred to the landfill in a month. So based on all this data, you have to estimate the amount of waste that is being transferred to the landfill. And your options are, I will just write the question. Yes, so you need to calculate the amount of waste that is being sent to the landfill in each month. Okay, as I can see that option 2 is the answer for per day of waste that is being sent to the landfill, and option 3, that is 7.5 tons, is the waste dumped in the landfill in each month. So moving on to the next question. It is a true and false type of question, and the statement is solid waste generated from a municipality is estimated by. Very easy question, and this one, similar one, we have also discussed in the last live session as well. So true or false? Yes, it is the correct statement as you have already highlighted. So moving on to question number 10. Which of the following methods so you have to choose an option which is used to calculate the feasibility of a transfer station. Your options are mass balance analysis, break even analysis, break even of distance analysis. So which one do you think? Yeah, any more options? One of the yes, option 2 is the correct answer. So we choose the location of the transfer station based on break even distance analysis. Similarly, moving on to the next question, again a very simple one, which asks you about the components of the solid waste which is not compostable. Option 4, absolutely correct, metals. Very easy questions these are. Now the next question is a numerical based one. Okay, so you have to determine the number of 7.5 meter cube containers which are required per week for collecting waste after compaction. The number of houses in a colony are 200 with 3 people in each house, and the waste generation rate has also been provided along with the compacted density or the specific weight that is to be filled in the 7.5 meter cube containers. So please calculate it and share your answers. Okay. Okay, so I can see most of you have attempted option 2 as the, oh, sorry, the answer is 2 containers. So we will quickly solve the question. Determine the number of containers. So number of houses is total waste generation. Number of houses into 3. So we have got number of houses into 3. That will be the total number of people who are present. And then multiplying it with 0.6, which is the waste generation rate per day, we will get the daily waste generation. So weekly will be just multiplied by 7. Now you require the number of containers, 7.5 meter cube. Waste in each container, 7.5 into 250. So this much waste can be held in each container. So in order to handle this 2520 kgs of waste, you require 2 containers. Sorry, this is not it. Although this is coming as around 3.4, numbers, but since that is not possible, so you require two containers. So this is the solution. Then moving on to question number 13, and from now onwards, all the questions will have multiple correct answers. So you have to choose. Will have multiple correct answers, so you have to choose accordingly. First one, that is question 13, is very easy. Which of the following vehicles are used as transfer vehicles for solid waste? Okay. So any thoughts? It has got more than one correct answer. Okay, so in here the correct answer is option 1, 2, and 4. Because two are rail cars, these cars are basically, I will show you one picture in Google that will be easy for you to understand. These are kind of train carts which are used for carrying solid waste. Okay, so you can see here that these kind of carts are basically called as rail carts, where they are used. These cabins waste can be dumped in there, and then like normal train bogies, they can be carried to different places. So these are the rail carts. Okay, so moving on to the next question. Which of the following are not the source, handling, and separation method of solid waste? Separation options are separation of domestic hazardous waste, curbside pickup of waste, separating biodegradable solid waste, and transfer vehicle transfer vehicle routing. So among the four, which are not the source, handling, and separation methods of solid waste? I will highlight the question that you have to choose the options which are not the source, handling, and separation method. Okay, so option 2 and 4, as I can see that some of you have correctly answered it. Option 2 and option 4, both of them are not the handling and separation method of solid waste because they both serve different purposes. If you want to see those source segregation and all, they will be included in option 1 and option 3. So moving to the next question, which is also the final question of today's live session, and a very easy one. Like, which of the following components can be sent for recycling units? Which of the following components of solid waste can be sent to recycling units? Okay, your thoughts? Option 1 and 2 are correct, but any other thoughts? Apart from option 1 and 2, maybe something else that can be sent for recycling. Okay, so option 3 is also can be sent to recycling. Both paper, plastic, and metal waste, these can be recycled. In plastic waste, like some can't be recycled, which can be your this single use, not single use ones, these plastic films which are present around the water bottles or these single use plastics. Sometimes people may find it difficult to recycle that. Otherwise, generally speaking, paper, plastic, and metals, these can be recycled, and not there is no point about recycling the vegetable waste. So these are the options, and these are the questions that we had in store for us today. I will quickly go through all these questions again so that the participants who have joined later, they can also take a look at them. So in question number 1, it was a material balance based question, and you have to choose the correct option of these four, wherein the first statement was statement 1, rate of accumulation of material within the system boundary. Second was rate of material flow into the system boundary, third, rate of material which is flowing out of the system boundary, and fourth is the generation of waste material that is taking place within a system boundary. So these 1, 2, 3, and 4, we have to build a relationship among the four of them. So in this, the correct answer was option B, I guess, because one is the rate of accumulation of material that I want to know within a system, that is option 1. This statement 1. 2 is rate of material that is flowing in the system. So whatever material is flowing into the system, I have to subtract the material that is going out, which is statement 3. Finally, adding if some waste material is getting generated in the system due to some reactions or other processes. So option B is the correct answer. That accumulation is equal to inflow minus outflow plus something that is generated in the system. Then the next question was, you have to find the number of moles of water that can be formed when 10 moles of oxygen reacts with 10 moles of hydrogen. So answer lies in this chemical equation wherein 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of water. So here you can see that the number of moles of water that is formed, it is equal to the number of moles of hydrogen that takes part in a chemical reaction, and the number of moles of oxygen, it is half that of the hydrogen requirement. So based on this question, you had been provided with the information that 10 moles of hydrogen takes part in a chemical reaction. So that is why the amount of water that will be formed, it is also 10 moles. But if, for example, in this question, I can modify it slightly. So in this question, let's say we have 20 moles of hydrogen and 8 moles of oxygen. So how many moles of water will be formed then? This is a question to everyone. I will wait for, let's say, 1-2 minutes for you to answer. Yes, 16 is the correct answer in this question. Reason being, there are 8 moles of oxygen. It reacts with how many moles? Twice the number of moles of hydrogen. So it reacts with 16 moles of hydrogen to form 16 moles of water. So that is why 16 moles is the correct answer. And if there would have been, instead of 8, let's say this is 20 and this is 8, then how many moles of water would have been formed? 20 moles of oxygen are there and 8 moles of hydrogen. Very simple and easy. Yeah, so I can see that the basic concept of this question has been understood by everyone. 8 is the correct answer in this way, similar to what was before. 8 moles of hydrogen is required and number of moles of oxygen required is half of that, which is already sufficient. 20 moles of us there, out of which 16 moles will be used to form again 8 moles of water. So this part is sorted. So moving on to the next question, it was stated that which of the following is or are not needed to be considered while designing the solid waste collection system of a community. So among all these options, which were determining the number of vehicles, routing, size of landfill, and time of each vehicle pickup, the correct answer was size of the landfill. Like, it is not the concern when we are trying to focus on the collection system of the solid waste. So in those instances, we take into look the routing, optimization, time taken for each vehicle to collect waste from individual households and then move across different routes, and also determining the optimum number of vehicles which are required. So option C was the correct answer, which is not considered while designing the solid waste collection system. Then in next question, the options were given and you had to choose the ones which are considered for backyard composting. So among these, size of the composting unit, yes, it is very important while going for backyard composting. Then mixing to maintain contact with air, that is of primary importance for any composting process. What is not that is why option 4, that which is both A and C, are the correct answers. Option B, that is methane released during composting, is not the correct one, because composting is basically an aerobic process, and like you can say that negligible amount of methane should be released while composting, because methane is basically an anaerobic reaction product, not an aerobic, not a product of any aerobic process. The next was a numerical based question wherein you had to determine the number of houses which are there in a colony, and you have been provided with some information, that is the occupancy rate per house is 3 people per house. Then the total waste that is generated, it is being compacted and filled in 2 containers each week. After that, you have been provided the waste generation rate and the specific weight of the solid waste after being compacted. So based on this, you had to calculate the number of households. So the occupancy rate is 3 people per house. Waste generation per week is 2 times. Then, because you have been told that 2 containers are being filled every week. So first is 2 containers are there. Then volume of each container 7.5, and the compacted density of the waste in those containers is 250. So multiplying these three components, number of containers into volume into density, we will get the total mass of waste that is generated per week. So now easy, daily waste generation is divided with 7. Per capita waste generation, you have been already shared 0.6 kg per day. So dividing the daily waste generation with per capita waste generation, you will get the number of people who are there, who are producing the waste, and then dividing the number of people by 3, because there are 3 persons per house. So then you will get the number of houses, which is almost 298. And the closest option here is 300. So option B was the correct answer. Then in the next question, you have been asked that which of the following waste management practices helps in diverting the waste being dumped at the landfill. So the first option is backyard composting of organic waste. So it is one of the correct answers, because if you do backyard composting, most of the organic fraction that is generated in households, that can be handled and treated again in that same place of waste generation. Then second was the generation of RDF, refuse derived fuel from solid waste. So if I have a mass of solid waste, it can be dried and compacted, and then those compacted like small capsules or bricks or pellets, you can say, they are then used as a fuel for different purposes, like they can be used in cement kilns, brick kilns and all that, instead of coal and all those materials. Third is recycling of solid waste. So recycling of solid waste like plastic, metal, paper recycling, they can also divert the waste from landfill. So that is why all the 4 options were correct. Now, moving on to the next question. Transfer stations are designed for, these are the 4 options. The correct answer is option 2. That is the primary reason for introducing transfer station, that is to minimize the cost of solid waste transportation. Minimizing the haul distance, that is just a component of it and not the complete. And one can't say that this statement alone is complete, because the cost is minimized. Why? The reason is, when the waste is collected from our households, we usually see that our collection vehicles are much smaller in sizes. So in case that there is no transfer station, those vehicles itself, those many number of smaller vehicles, they have to directly go to the landfill. So it has been already observed that the fuel consumption in those cases from these vehicles, they are significantly higher. So that is why when transfer station is introduced at some intermediary point, these smaller vehicles, they first take their waste to the transfer stations, dump it there. From there, the bigger trucks or waste collection vehicles, they carry those compacted wastes along with them to the landfill. So in that way, what happens is that uh, when I am using bigger size vehicles like trucks and all, it has been observed that the waste collection, it becomes cheaper because the fuel consumption reduces significantly. So that is one of the reasons why transfer stations are designed to minimize the overall cost. Also, what happens that sometimes we can compact the waste also in transfer station, that actually most of the times it is done. So when I am compacting the waste, so more amount of waste can be loaded in a single truck. So that is another positive that comes out of transfer station. Then in next question, it is a mass balance type of question. You have shared that the solid waste generated per day was 2 tons. There's a transfer station where the solid waste was dumped first or taken to. Not the correct, dumped is not the correct term. Like the waste is taken to a transfer station. From there, it is 0.75 tons is going for recycling, zero point 0.5 is incinerated, and rest zero point 0.5 is composted. So you have been asked like what amount of solid waste per month is being disposed in landfills. So the correct answer was 3. That is the monthly amount of waste that was being disposed in landfills, and the solution was very easy. Whatever data that is given here, that these are for daily waste generation and transfer. In order to convert into monthly, we have to multiply it with 30 or 31. We will see what comes with 30 first. So total waste, I have got 2 tons per day minus all the other components. 0.75 goes for recycling, zero point 0.5 goes for incineration, and zero point 0.5 for composting. So the answer is 0.51, 1.75. This is into 0.25, which is equal to 7.5 tons, the monthly amount of waste that is being disposed at the landfills. In the next question, it was, I guess, a true and false type of question, wherein the statement was that the quantity of solid waste generated from a municipality is estimated by weight volume analysis. So true is the correct answer, because we discussed the same question in the previous live session as well. Then, which of the following method is used to calculate the feasibility of the transfer station? Among all these 4 options, mass balance one, break even distance, energy balance, or none of the above. So in here, the break even distance analysis, this is the correct answer, because transfer station should be located at a certain intermediary point between the colonies or the household areas or the residential complexes from where the waste is to be collected, some area, and finally a landfill that is located at some distance, considerable distance from those collection areas. So in between somewhere the transfer station lies. And now my smaller vehicles, they are carrying the waste to the transfer station, and from there it goes to the landfill. So the location of the transfer station is determined based on the break even of distance analysis, which will give us a point wherein the optimized distance is obtained of the transfer station from both landfill and the residential complexes or areas. So that distance is also the one that is associated with minimum cost as well. Now, the next question was non-compostable component of the solid waste. Very easy question. Among these 4, only metals are the non-compostable component. Now, the next question was a simple numerical based question, wherein you have been asked to determine the number of 7.5 meter cube containers which is required each week. So the volume of individual container is 7.5 meter cube, and the waste which is being filled in it, it has been already compacted. That information is already shared. And now the colony has 200 houses with 3 people in each house. waste generation rate per capita per day has been shared with you. Specific weight of the compacted solid waste, it is also disclosed. So based on it, you have to calculate the number of containers which are required each week. So first things, we will start with the daily waste generation, which is number of houses multiplied by people in each house, which will be total number of people who are there. So that is 600. Now multiplying 600 with daily waste generation per capita, that is 360 kg of waste, which is generated daily. So weekly generation, just multiply it with 7. Now we know that 7.5 meter cube is the volume of each container, and the compacted density of the waste is 250 meter cube, kg per meter cube. So the mass of weight that can be filled in each container will be simple, volume into density, that is 1875 kg. And the number of containers you need each week is 2520 kg is the amount of waste individual container can hold this much. So divide the two, you will get around 1.3 number of containers. But this 1.3 number of containers doesn't make sense. Obviously, you need more than one container to take care of the extra 1.3 fraction. So that is why two containers are needed. Now, the next question is, which of the following vehicles are generally used as transfer vehicles of solid waste for solid waste? Now, the correct answer is trucks. We all know that trucks are used. We all know that trailers are used. The other comparatively less known component is rail cars. Rail cars are normal, those cargo kind of bogies in trains which are open from the top. So the waste is dumped in those containers, and then similar to the train engine, one carries those waste to the desired location. Now, the second last question was, which of the following are not the source handling and separation method of solid waste? So among these options, you have been asked which is not the source segregation and separation, those kind of stuff. So option A is separation of domestic hazardous waste. So this is a component of source segregation. Curbside pickup, this is not actually the source segregation, because let's say you are dumping the waste in at the curbside in some bins and you are not segregating the waste, it is all a mixed waste that is dumped there. So then it is very difficult to separate it. The vehicle, collection vehicle which is coming, it will directly pick the mixed waste only. The third option is separating the biodegradable solid waste, which we most of us sometimes do at our households for composting it or using it for any other nutrient material for the plants. So that component is again source segregation. Finally, transfer vehicle routing, it is of course a different concept altogether. So option 2 and option 4, these two are not the components of source handling and separation of solid waste. Moving on to the final question, which is very simple one. Out of these four, which components of solid waste can be recycled? You know that paper can be recycled. Most of the plastics can be recycled except those single-use ones. It is very difficult to recycle them because the collection itself is a challenge, and then most of the times they're contaminated as well. Then those thin film plastics which are present in the wrappers of different uh, bottles or other packagings, those are also very difficult to recycle. But as a whole, plastic waste, we know that they can be recycled comparatively much easier. Paper waste, plastic waste, and finally metals. These three components, they are considered as a recyclables in the solid waste stream. So these were the 15 questions that we discussed today. In case if you have any doubt, you are always free to unmute yourselves and share that with us, or you can also use the chat box to type your doubt or query. Hello, hello, हेलो. आवाज आ रही है क्या? हाँ, अरे कुछ नहीं, वो तब गलती से फोन लग गया था मेरा, वो टीए ड्यूटी चल रहा है. বিনোদ, দুটো নম্বর আছে, আরেকটা সেভ করলাম. ওটা আসলে হ্যাঁ বলে দে. Yeah, you can ask that question.
So I have to ask about that assignment.
Yes.
In that assignment, the question was which one of the following statement was incorrect, and the
Okay.
options were
Which of
if
the
you
following
have they
statements
have
were incorrect? Right.
so first option was solid waste generation rate is equal to solid waste collection rate.
Okay.
Okay.
Wait,
Second
I will
was
just write the options as well on the screen so that you can confirm.
okay.
Solid waste generation rate
Rate
equal
is
to solid
equal
waste
to solid waste
collection.
collection rate.
Okay.
Second was backyard composting negatively contributes to solid waste collection rate.
Composting negatively contributes.
Negatively, no, negatively contributes to
Okay.
solid waste collection rate.
Fine.
Third one was informal selling of solid waste,
Informal.
selling of solid
Okay.
waste to kabadi wala
Hmm.
positively contributes to
Yeah.
solid waste coming to the ULB facilities.
Solid waste coming to
Coming
the
to ULB facilities.
ULBs, urban local
Hmm.
bodies. Okay.
Okay. And fourth one was all of the above.
And you have been asked like which of these is incorrect.
Incorrect.
Yeah.
So
So yeah, your thoughts.
what I answered was A. Solid waste generation rate is equal to solid waste collection rate, which is wrong, incorrect statement.
Yeah.
Okay. And second one,
Hmm.
backyard composting negatively contributes. This is also negatively contributes to solid waste collection rate. This is also incorrect
Okay.
because it positively contributes. It reduces if someone is using compost at their
Hmm.
backyards, it will positively reduce the solid waste generation.
Okay.
So I answered
So
B also incorrect.
so you are okay. So you are saying this is also incorrect.
Yes,
Fine. Yeah.
and
And this one.
C, I think C was correct as I understood because informal selling of solid waste kabadi wallas positively contributes to solid waste coming to UL base
Okay.
because they earn money from this and uh, that eventually this will also reduce the solid waste collection or solid waste
Okay.
generation. They will directly send it to recyclables and they will earn their money.
Hmm.
And D was all of the above. If
Okay.
any
So
one
I
of
think this one
above
was the
will,
correct option that was there. So what you are telling that is correct, but from the perspective of solid waste management. So what you told that is absolutely correct because backyard composting it negatively contributes. Like you are saying, this statement is can be incorrect if it would have been backyard composting negatively contributes to the solid waste management. Then it would have been incorrect. What the question states, it is kind of you should have to look at it from the perspective of collection only. Simple collection.
hmm,
Like this is incorrect, that is so we all know. This is
hmm,
plain and blatant incorrect. Why this is also incorrect? The reason is backyard composting negative. This is correct rather, sorry. And you have been asked which of these incorrect. Fine. So this is correct. Reason being, backyard composting. What happens? Why it negatively contributes to the solid waste collection rate is that when I'm looking at it purely from the perspective of solid waste collection rate. So I have got 100 kgs of waste generation, which has all organics, inorganics, component, everything. So I have to collect that waste. So purely from the perspective of waste collection, I'm looking at it. And if let's say some people are composting it in their backyard, so some amount of waste that is generated, it is not really collected. So purely from that perspective, this statement is correct because the amount of solid waste generated, it is not really being collected. The amount is less. But whether this is the nice thing or not, then of course the correct answer, what you have already told, that it is a good thing that people are going for backyard composting because then I have to collect less amount of solid waste. So that is why I have to collect less amount of solid waste. That is why negatively contributing the solid waste collection rate. So the waste collection rate will also reduce. That is why it is the correct answer. So the next thing is informal selling of solid waste to kabadiwalas positively contribute to the solid waste coming to ULBs. I think this should be incorrect in that perspective, because when same concept as this one, informal selling of solid waste to kabadiwalas, that means we are selling it to them, and then those kabadiwalas, they most probably send it to other recyclable recycling or reusing centers, those areas where that material is again uh, like processed through different units, and then something else is created out of it. So in that way, the amount of waste that is being collected, it reduces. So the waste that is coming to the ULBs, it is reducing. So that is why it should have also been negatively contributes, not positively. So in that way, I think option this one, sorry, statement is incorrect, this statement is also incorrect, and you had to choose the options which are incorrect. So in that sense, option A and option C, these should have been the correct answer. And what was that the solution was saying?
Same as you told,
Yeah,
A
option,
and C.
yeah. So that is why option A and option C is what the answer is. Because you have to purely
But
look at it
also,
from the perspective of collection, not management and what is better, what is not. That
okay, got it. But answer D, all of the above, that will also be an incorrect because
yeah, that is also
uh,
incorrect. Yeah.
you,
So only option A and option C. Okay. If anyone else is having any doubt, they are always welcome to please unmute themselves and share their opinions, or if they have any confusion at some point. Otherwise, just as a note that today's live session, the questions we had to discuss, that is has been achieved, and it is not mandatory to uh, like join this session up till the session is from 7 to 9. So it is not mandatory to we keep log in until 9. If you have no other questions, you are always free to leave the meeting whenever you want.